Hello everyone, welcome to the Binance Chain Club. In today's video, we are continuing our series on building a real-world crowd sale on the Binance Smart Chain. This is the third part of the series, and it will focus on using OpenZeppelin contracts for solidity development. In this video, we will cover the following topics. Firstly, understanding what OpenZeppelin is in the blockchain. Second, the benefits of using OpenZeppelin contracts. Third, the common use cases for OpenZeppelin contracts, including token standards, access control, MEFT, re-entrancy protection, pulsable, crowd sale, distribution, emission, and validation. Lastly, you will learn how to use OpenZeppelin contracts on the Remix IDE to build and test secure smart contracts. It is important to note that understanding OpenZeppelin contracts requires some fundamental knowledge about blockchain and solidity programming. If you need a refresher, we recommend checking out the first two parts of this series. And without further ado, let's get started and learn how to build and test secure smart contracts using OpenZeppelin contracts on the Binance Smart Chain. What is OpenZeppelin in blockchain? OpenZeppelin is an open source platform that provides tools for writing, deploying, and managing decentralized applications on the Ethereum blockchain. It offers a library of reusable, secure smart contract templates such as token standards, access control, and advanced contract interactions to make it easier for developers to create reliable and secure smart contracts. The goal of OpenZeppelin is to reduce the risk of errors and save time for developers by building pre-built, better tested contract templates that can be easily integrated into your projects. So why OpenZeppelin contract? There are 6 reasons why you might want to use OpenZeppelin contracts in your smart contract development. Firstly, on security, OpenZeppelin contracts provides a set of pre-built, better tested contract patterns that have been audited by reputable third-party security firms. By using these contracts, you can reduce the risk of errors and security vulnerabilities in your own code. Secondly, reusability. OpenZeppelin contracts provides a wide range of common contract patterns such as token standards, access control, and advanced contract interactions. By using these pre-built contracts, you can save time and reduce the complexity of your own contract development. Thirdly, interoperability. OpenZeppelin contracts provides a consistent and well-documented interface which makes it easy for different contracts and dApps to interact with each other. Fourth, community. OpenZeppelin Contracts is an open source project with a large and active community. This means that you can benefit from the contributions and feedback of other developers, as well as access to a wealth of documentation and resources. Fifth, flexibility. OpenZeppelin Contracts is designed to be flexible and extensible, allowing you to customize and extend the contracts to fit your specific needs. Lastly, support. OpenZeppelin also provides a suite of tools for testing, deploying, and interacting with your contracts, including the OpenZeppelin CLI and the OpenZeppelin test environment. Use cases for OpenZeppelin contracts. OpenZeppelin contracts provides a number of standard contract patterns that can be used to implement common functionality in smart contract development. Here are a few examples of the types of contract standards provided by OpenZeppelin. Firstly, we have token standards such as the ERC20 and ERC721 and ERC777. All these 3 token standards here provides common interfaces for creating, managing, and transferring fungible and non-fungible tokens on the Ethereum blockchain. Firstly, the ERC20 token is a widely used token standard on the Ethereum blockchain. It is a technical standard that is used for creating smart contracts that implement tokens. This standard defines a basic interface for fungible tokens on the Ethereum blockchain. It includes methods for querying token balance and transfer, as well as events for tracking transfers. Thus, it is useful for smart contracts related to voting rights and staking. The ERC20 contract from OpenZeppelin is the base implementation of the ERC20 interface, and it has various extensions. These extensions include different functionalities. For example, the ERC20 detailed contract adds details including name, symbol, and decimals to the ERC20 contract from OpenZeppelin. And another example is the ERC20 cap contract, which is used to designate addresses for tokens with a maximum limit. To know more about ERC20, what we can do is head to OpenZeppelin website to find ERC20, and what you can do here is actually read up on what ERC20 interface is. Generally, it will tell you what is it for and what are the available functions that you can call by having a ERC20 token contract. As mentioned earlier, ERC20 token is a base interface and it can be extended with extensions contracts such as ERC20 detail that helps you to supply the name, symbol and decimals to have a more detailed contract, or you can even extend it to ERC20 mintable, whereby you will have your ERC20 token as usual, all the functions here, and what you can do is that by implementing ERC20 mintable, by extending it to this, you can have additional functions of the minter role, and you can even go to ERC20 cap. What you can do here is you have additional functions that ERC20 cap will provide for your contract itself. So these are called extensions. Now, going back to the token standards contract, for ERC 721, these standards defines a basic interface for non-fungible tokens on the Ethereum blockchain. It includes methods for querying token ownership, metadata, and transfer, as well as the events for tracking transfers. ERC 721 is the top solutions for non-fungible tokens. Like all other tokens, NFTs represents ownership both of virtual and physical assets. These assets are likely to include collectible items like antiques, cards, or arts, physical assets like houses or cars, negative value assets like loans. Each token is unique and has ownership and status that must be tracked. And its extensions include mintable, metadata mintable, burnable, and pulsable. So, going back to OpenZeppelin website, what we can do to find out more is click on ERC 721, same as ERC20. You can find out what 721, what does it serve. Take a look at its base functionality. Are all these functions, does all these functions satisfy what you need for your contract? And if it does not satisfy, do take a look at the extensions to find out what are the possible functions that you need to implement so that you know what contract you can extend your base contracts to. ERC 777 is a token standard that is an extension of the ERC20 token standard. It is designed to improve upon the functionality of ERC20 tokens and provide more flexibility and control for token holders. Some of the key features of ERC 777 includes operators, which allows for the transfer of tokens on behalf of the token holder. This feature can be used for things like staking, liquidity, provision, and more. Hooks, which allow for custom logic to be executed on token transfers, enabling advanced use cases such as token burning, locking, and more. Safe transfer, which allows for the execution of a contract's fallback function before a token transfer, allowing for more security in smart contract interactions. Notifications, which allows for the contract to send events on token transfer and other actions, providing more transparency for token holders and external contracts. While similar, the ERC77 token and ERC20 token differ in complexity. ERC777 aims to provide a more flexible and powerful token standard compared to ERC20. Likewise, you can visit the OpenZeppelin websites to take a look at ERC777. For the second use case, OpenZeppelin provides access control contracts that allow for controlling access to smart contract functionality by adding an owner and operators. These contracts enable functionality for selective restrictions and basic authorization control, including address whitelisting and signature-based permissions management. Controlling access is one of the main use cases for OpenZeppelin. These contracts allow for determining who can access specific resources and functionalities in a system, such as restricting voting, minting, and sending transactions to specific entities. This provides a level of security and flexibility for managing access to smart contract functionality. Third, the math contracts, such as SafeMath, which provides mathematical functions such as addition, subtraction, multiplication, and division with safety checks to prevent overflow and underflow attacks. For the fourth use case, re-entrancy guard contracts, which protect against re-entrancy attacks by using mutex mechanism. For the fifth, we have pausable contracts, which provide a way to pause and unpause a contract, allowing you to temporarily halt its functionality. Another prominent use case is the crowd sale contract. The crowd sale contracts, which provide a way to manage a crowd sale, including functionality for token distribution, whitelisting, and a cap on the total number of tokens sold, It includes a base contract which implements fundamental crowd sale functionality in the simplest form. The base contract can be extended in order to satisfy your crowd sale specific requirements. The distribution, which includes extensions of the base crowd sale contract, which can be used to customize the completion of a crowd sale. The emission, which includes extensions of the base crowd sale contract, which can be used to mint and manage how tokens are issued to purchasers. The validation, which includes extensions of the crowd sale contract that can be used to enforce restraints and limit access to token purchase. And these are just a few examples of the contract standards provided by OpenZeppelin. The library includes many more contracts and functionalities to cover a wide range of use cases and scenarios. At this time, you know the answer to the questions of what is OpenZeppelin, and you also understand what OpenZeppelin contracts are. We'll look at OpenZeppelin contracts that are related to the ERC20 token standard and elaborated on OpenZeppelin example use cases. Now, it is time to see how we use OpenZeppelin contracts on the Remix IDE. The general steps to do so is of the following. Generally, you will first go to the OpenZeppelin Contracts website and download the latest version of the contracts. Then, you open the Remix IDE in your browser and create a new file by clicking on the plus button. And in the new file, what you want to do is import the OpenZeppelin contracts by adding the following line at the top of your file. Next, you can also import other contracts from the OpenZeppelin library as needed for your smart contract, and then you can proceed to write your smart contract code, making sure to inherit from the imported OpenZeppelin contracts as necessary. Once you have written your code, you can use the Remix IDE's built-in compiler to compile and test your smart contract. You can also use the Remix IDE built-in test functionality to test your smart contract's functionality. And once you're satisfied with the functionality and security of your contract, you can deploy it to the Ethereum blockchain using a compatible wallet or blockchain explorer. Now that we have a rough idea on the workflow, let's take a look at a quick example on how to implement an OpenZeppelin contract with extension of our choice on Remix environment. So for this video, we're not going to go in details in terms of implementing the OpenZeppelin contract on our own, but rather, let me introduce to you the tool called Contract Wizard, which is an interactive generator that can bootstrap your contract according to the components offered in OpenZeppelin contracts. So in this tool, it gives a UI that allows us to select the components and features we want to quickly generate a boiler template with our desired OpenZeppelin contracts. So for example, I want to implement a ERC20 token contract. I will select on ERC20 here. And then what I'll do is input in my token details such as its name, symbol. So for example, BNB chain. For symbol, I put BNB. And what pre-mint here does is that it represents the quantity that your contract is going to mint and supply to users. So I'll put 1000. So it will generate the codes accordingly. As you can see here, the underscore mint function was called, which is a function provided by the ERC20 token. Now, if you go to the ERC20 token GitHub repository, you can see the underscore mint comes from ERC20. A point to note is that when using OpenZeppelin to build your own distributed applications, for security reasons, you should not modify the frameworks-based contracts, libraries, and interfaces. In order to leverage and extend their functionality, you are encouraged to inherit from them or combine them with your own contracts. So what this means is that, for example, we want to have the features of mintable and pausable. What we do is we click on this two here, mintable and pausable. And what the exemplary code does is that it will extend the contracts from the library to add custom functionalities that we want, such as the pause and unpause functions that comes from the pausable contract. And also the use of only owners to indicate that these functions can only be called by the contract owner, which is made possible with the ownable contract. Although the code is simple for this example, it actually demonstrates to us the right way on how we should go about in building a complex, custom contracts while still leveraging the security and reliability of the pre-built contracts. And with this shortcode, we can actually open this code in Remix and compile and deploy this contract to the blockchain. So as you can see here, this is the code that we actually generated from the contract wizard. All you need to do now is to just compile it and deploy it. So let's go ahead and check it out. So make sure you select the correct contract, click deploy. Now deployed successfully. Let's check out all the functions that's available for you to call as the owner. You realize that even though the code here only has a few functions, but there's actually a lot of functions over here for us to call. And that is the reason because this contract is actually extended to ERC20, pausable and ownable contracts. You are able to use all the functions that is within this contract itself. You can do this by checking in each of these OpenZeppelin documents here. So for example, for ERC20, these are all the functions available for you to call, and all these functions actually appears here. For ownership, these are all the functions that's available for calling, such as transfer ownership. Let's take a look. We can actually see transfer ownership here, and these functions comes for ownable. For pausable, these are all the functions that's available for calling, increase allowance and decrease allowance. You can also find it here. So this is what extending your contract means. By extending, you do not have to rewrite all these functions from scratch. And what you can do is just leverage onto all these pre-built functions that has already been tested and ready to go. All in all, OpenZeppelin Contracts is a valuable resource for smart contract development on EVM network, providing a set of secure, reusable contract patterns that can save developers time and reduce the risk of errors. By using OpenZeppelin Contracts, developers can focus on building the unique and custom functionalities of their projects, while still leveraging the security and reliability of pre-built contracts templates. And with that, we've come to an end to this video. I hope this video has helped you to gain a deeper understanding on OpenZeppelin for Solidity development. If you have any questions or input, do comment at the comment section down below, and remember to like and subscribe. Have a nice day.